Example 2. Example 2 has x squared plus 6x plus 5 equals 12 by completing the square. So we're going to go ahead. We're going to follow our rules. First rule is to make sure that a is always 1. Is a 1? Yes, because a is whatever is in front of x squared. And remember that standard form. So rule number 2 is that we're going to make room for c. So absolutely, I need to move positive 5. How do I move? Oops. How do I move positive 5? I subtract 5. Very good. So I'm going to, bear with me here. I'm going to subtract 5, and I'm going to subtract 5 from both sides. Remember, you got your river. Okay, and you end up with x squared plus 6x. I'm going to make a little room for my perfect c. And 12 minus 5 is 7. Let's go ahead and figure out what is the perfect c. Now remember, the formula was take the middle term, divide it by 2, and square it, right? So what is b? Well, b is, let me see if I can, b is right in front of x, and so is 6. So therefore, b is equal to 6. Let me go ahead and plop that in. What's 6 divided by 2? 3. Good. And 3 squared is 9. Outstanding. So this is the perfect c. 6 divided by 2 is 3. 3 times 3 is 9. So what we want to do is we want to go ahead and add that 9 to both sides. Let's bring it on down. Okay. Now we want to go ahead and rewrite it so that it fits like this. Go ahead and section this off. So remember, in order to find the number that goes right here, I just figure out what is b divided by 2, right? I just have to take half of b. So what is half of 6? Good, 3. So all I'm going to do is take x plus 3, and that is equivalent to this. And if you need proof, let me show you. Remember, here I'll just do it kind of real quick off to the side. X plus 3, x plus 3, x squared goes here, 3x goes here, 3x goes there, and 3 times 3 is 9. And when we add those, we get the 6x. So see how you have the x squared, you have the 6x, and you have the 9. So this is equivalent to this. Now we want to go ahead and take the square root of both sides because we want to get rid of the exponent of 2. And when we do that, we end up with x plus 3 equals not just 4, but plus or minus 4. We're going to go ahead and split that up into 2 problems. The first problem will be x plus 3 equals 4, and the second problem will be x plus 3 equals negative 4. Let's go ahead, subtract 3 from both sides because that's how we move positive 3. Ladies and gentlemen, x will have 2 values. X will equal 1, and x will also equal negative 7. When I write it in a solution set, I use my curly brackets. I put my smallest number first, followed by my next largest number. Ladies and gentlemen, this is the solution for this particular quadratic. Okay. I'm going to pause here and start a new video. And after this, hopefully we get some practice in, okay? All right, ladies and gentlemen, welcome back. We're here for part 2 of 9-4, and we're picking up where we left off with example number 3. So let's go ahead and solve this. Negative 2x squared plus 36x minus 10 equals 24 by completing the square. No, no, no. I can continue. Okay, that noise in the back, that was Joshua. Just saying. Okay. Anyway, so we're going to do this by completing this square right here, okay? First thing we have to do is get a to be equal to 0. What is the value of a? Remember, a is the number in front of x squared. So it is perfect, okay? So Joshua's going to help explain this. He'll be the person in the background, okay? So speak up if you're going to speak. You got to speak in the microphone, okay?
Hi.
Okay. So, Joshua, how should I get rid of the negative 2?
By re inverting into plus two,
By
then
doing what?
moving inverting into plus two, like adding plus two, then moving over to plus two.
Oh, okay. That's if we want to move the whole thing, right?
Oh,
But if I actually want to split it from x squared, like what is negative 2 and x squared actually doing?
oh, the multiplying, so you gotta divide it.
Exactly. So you always do the opposite, right?
Mm-hmm.
So we're going to divide by negative 2.
Teaching lesson.
Yeah. And we divide everything by negative 2,
Yeah.
right? Okay.
Mm-hmm.
So then I end up with x squared. Then I end up with what? I'm going to test you. Well, positive divided by negative is definitely a
Negative.
negative. And 36 divided by 2 is, chime in if you want. This is without calculators, folks.
I'm doing it in my head right now. I forget everything.
What's half of 30?
15,
What's half of 6?
80, so 18.
Yes. Okay. So minus 18x, right? Oh, here's an easier one. Negative 10 divided by negative 2.
Positive 5.
Positive 5. Very good. Okay. So then, oh, I'm recording. Yeah. So 24 divided by negative 2 is
Negative 12.
negative 12. All right. Beautiful. Now what I got to do is make room for my perfect C.
Mm-hmm.
So now's when we're going to move the positive 5. Y'all know how to move positive 5?
Minusing and subtracting it by the other side.
Exactly. And what I do on one side, I got to do on the other. Okay. Let's see. Okay. So we're going to go ahead and move that positive 5 over. And I've got x squared minus 18x. Let's leave room for our perfect C. And then I've got negative 17, right?
Yeah.
So we got to use our formula for the perfect C by taking half of b and then squaring it, right? So b has a value of
18.
negative 18. Don't forget the negative. And then we divide that by 2, which is what? Negative 9. And then we square that. And negative 9 times negative 9 is
81.
81, right? That's our perfect C. Okay, so I'm going to go ahead and add that to both sides. Plus 81. Yeah, got to do it both sides. Okay. And then I'm bringing it down. X squared minus 18x plus 81 equals, and I already did the math, so it's 64. Okay. And then, let me double check. Yeah, 64. Just,
So
I
you
don't
got
want to.
everything ready in advance.
Yes, I do. I'm prepared. So now when I do this, I can rewrite this like x something squared equals 64, right? Okay, and we talked about earlier in our previous examples how the number that goes there is just b divided by 2. So what was b divided by 2?
Equal 9.
It was 9, right? Negative 9. Okay, so that's the number that's going to go in there. Now we take the square root of both sides. And then we have x minus 9 equals, what's the square root of 64?
88.
8. But as you learned earlier, wink, wink, it's either plus or negative 8, right? So now we're going to split it into two problems. X minus 9 equals positive 8, or x minus 9 equals negative 8, right? One step, all I got to do is what to get x all by itself? Move the 9 by adding 9, right? Both sides. Okay? And then we end up with x is either going to equal 17 or x is going to equal 1. And I'm going to write it in my solution set like this. We're going to pretend that's a curly bracket. And I've got, what is that supposed to be? Hold up.
17.
Oh, that's ugly. All right, 17 And so I'm going to put my small number first and then my large one. All right?
Yeah.
Yeah, clear as mud. And there we are. All right,
Well, I knew nothing that was going on, but I'm pretty sure I'll run it today.
cool. All right, let's go ahead and pause here for a second. Okay, example for canoeing. I think, yeah, we're on. Suppose the rate of the flow of an 80-foot wide river is given by this equation, where r is the rate in miles per hour and x is the distance from the shore in feet. Joaquin does not want to paddle his canoe against a current that is faster than 5 miles per hour. And at what distance from the riverbank must he paddle in order to avoid a current of 5 miles per hour? So I kind of have to draw a picture here, okay? Um, what I'm going to do, I think I'll do it something like this. Let's see if this will work. Okay, that works for me. So the R, which is typically where Y is, right? That's our Y axis, is the speed. It's the rate. Um, it's the rate in miles per hour. So this is our rate of speed. And then here, X is the distance in feet. So if you think about this like this river, right? It says that the river is 80 feet wide. So let's see if I got like a blue, like here. This is basically all of the river, okay? This is one bank of the river, right? This is like where the water hits the ground, right? And then all of this is the river, okay? I'm just going to kind of draw this right here. All of this is this river, and this river is 80 feet wide, okay? Now, here's the deal, is that it says it's negative up front. Okay, that's a typo. That should be an exponent of 2. It's negative up front. And so we're kind of looking at something like this, where it's kind of like that. Now, keep in mind that right here, that's pretty fast, right? This is the fastest that it's going to be. And that's right in the middle of the river. The closer it is to the bank of the river, okay, the slower that it's going to be. So this guy that's paddling the boat, he wants to stay kind of close to the bank because he doesn't want to get past the river going 5 miles per hour, which means that he's trying to, somewhere in here. Let's see if I can do this, okay? So here is this line, right? This is the slow areas. And we kind of want to figure out, how far away is it from here to there and from there to there. And so we're going to calculate that using completing the square method, okay? So first of all, this faster than 5 miles per hour, okay? He wants to stay, so I think of it as like this. The rate, negative 0.1x to the second power plus 0.8x has to be less than or equal to a rate of 5 miles per hour. This is how we would set up the problem, okay? Now we're going to use our completing the square. I think the first thing we need to do is kind of just make this a equal 1. And in order to make that happen, 2 things. We're going to have to change the sign. So I'm going to make this positive. This is going to become negative. And this is going to become negative. And then the second thing is I'm going to have to actually just multiply by 100, which basically moves all the decimal points 2 times to the right. So what we end up with is 1x squared minus 80x, because I'm multiplying everything by 100 again, okay? And I end up with negative 500 on this end, okay? Now I need to find my perfect C. The perfect C is going to be half of 80 and then I square it. So that's negative 40, and I square that, 1600. Okay? I'm going to add that to both sides. That's plus 1600 plus 1600. I end up with x squared minus 80x plus 1600 less than or equal to 1100. Okay? I'm going to go over here, and I'm going to rewrite this as squared. So I just take half of negative 80. Okay? And now I am going to take the square root, both sides. On this side, I have x minus 40 being less than or equal to, and remember it's going to be plus or minus, and I'm going to come up with a digital or a decimal approximation. So let me go to my calculator. Probably have some junk on there from old stuff. Let me add a calculator page, and we're going to do the square root of 1100. And I get like 33 point, and I'm just going to round it like 33.2. Okay? So let's go over here. It's going to be approximately 33.2. Okay, and we're going to split it into two problems. One with a positive, one with a negative. And let me add the 40 to move that over. And x will be less than or equal to 73.2. And this is going to be x is going to be less than or equal to, let's see, almost 7. It's like 6.8. Okay, and our unit is, what is the distance in? It says distance 80 foot wide, right? So absolutely, we're looking at feet. See if there's another indication of that. It says x is the distance from the shore in feet. So again, we're looking at feet, okay? So when I look at this, I know that my two answers are 73.2 and 6 point, let me make that real clear, 6.8. Let me kind of draw that on here. That means that this right here is 6.8. And the other is 73.2. Okay? So basically anything that's 6.8 feet or less will work, will be slow. And this part, if it's more than 73.2, it will be slow enough for him to paddle the boat. Yes? Let's go ahead and write that in a nice formal sentence. Okay? He needs to remain less than 6.8 feet from the bank of the river, or further than 73.2 feet from the bank of the river. Okay? Okay, this concludes 9-4. If you have any questions, please bring it to my attention, and I will see you soon. Thank you. Bye.